Hello. This is a presentation on the Atlas BioShield and what we've been able to do. This is a global biorisk command surface. Imagine waking up tomorrow and discovering that somewhere on Earth something biological has changed. A respiratory anomaly is appearing in several clinics. An unusual pathogen is detected in wastewater. Livestock mortality is increasing. Crop disease is spreading across farms. The problem isn't necessarily that these signals exist. The problem is that they are fragmented. One system sees the hospital data, another sees wastewater, another sees animal health, another sees agriculture, and decision makers often see the consequences only after the signal has become a crisis. The BioShield is able to change that. It's a global biorisk command surface designed to answer three questions in real time. What is happening? Why is it happening? And what should happen next? At the center of Atlas BioShield is a simple philosophy. Don't build another dashboard, build an interface for planetary biological awareness. The home screen is a living map of global biological risk. Instead of displaying conventional news articles, the Atlas BioShield is able to visualize the biological signals. Red represents active high-risk clusters, orange represents emerging anomalies, yellow represents suspected signals, green represents stable regions, and pulsing nodes represent something even more interesting, unknown biological events requiring investigation. The map isn't simply showing geography, it's showing the state of Earth's biological immune system. Let's start at the global level. Here we have our planetary map. We can switch between a traditional flat projection and a three-dimensional Earth. But the real power comes from the layers. We can activate the infection risk, human movement, agricultural risk, wastewater surveillance. I think it's over here. You can be able to shift from infection, the travel, you can see travel, the agri, and then the wastewater, the red. And eventually other environmental biological indicators. Now imagine that an anomaly begins appearing in East Africa. The system doesn't wait for a headline. A cluster begins forming on the map. We can zoom from the continent to the country, to the city, and eventually towards individual facilities or surveillance locations, depending on the available data and permissions. When I select this cluster, the Atlas BioShield immediately changes context. We're no longer looking at the planet, we're looking at an event. On the left is the signal intelligence feed. This is intentionally not a news feed. We don't want articles, we want signals. Each signal tells us where did it originate, what biological domain does it involve, how severe is it, how quickly is it changing, where did the evidence come from, and how confident are we. For example, Nairobi East can show the respiratory anomaly. We can see three clinical sources that have reported an unusual increase. A wastewater sensor is showing a correlated signal. The observed velocity is increasing, and the system currently assigns a confidence score of 0.78. And here's an important principle. Atlas BioShield does not confuse detection with truth. A signal is not automatically an outbreak. It's an hypothesis requiring verification. That's why every signal carries a trust layer. We also have the trust and verification sector. We need to go deep into implementation. What we have is merely a prototype version one. So I think I'll be able to skim through what we already have. Uh, every biological signal has provenance. We're able to show the source verification, laboratory confirmation status, AI confidence, supporting evidence, and an auditable record of how the signal evolved. This is critical because a planetary biosecurity platform cannot become a machine for amplifying misinformation. The system needs to distinguish between observed, inferred, simulated, and confirmed. These are not the same thing. Atlas BioShield therefore makes uncertainty visible. Instead of saying this outbreak is happening, the system might say an anomalous signal has been detected. Current confidence 78%, laboratory confirmation pending. That distinction could be the difference between responsible early warning and unnecessary panic. Okay, the next we have the outbreak timeline engine. Now let's open the event timeline. I'm not sure whether we have it here. But I think considering this is version one, we might be able to see a few things and be able to explain it. Probably we need to add more. Okay, sure. Later on. This is where Atlas BioShield turns raw signals into a story. First, you can see anomaly detected. Next, you can see the verification has been initiated. Next, you can see the additional signals detected, the spread model generated, intervention deployed, containment status updated, and here's the key interaction. The time scrubber, I can drag it backward. Now I'm looking at the event 6 hours after the first signal. You can be able to move forward 12 hours, 24, 48, 72. We're effectively watching the biological event evolve through time. This gives investigators and decision makers something incredibly valuable: context. Instead of asking only, where are we now? We can ask, how did we get here? Then we can introduce the intelligence layer. The AI response copilot. This isn't designed to replace epidemiologists, public health officials, clinicians, and emergency managers. It's designed to accelerate the reasoning. A user can ask, is this signal more likely to be real or noise? The system examines the available evidence and explains its reasoning. We can ask, what regions are most likely to experience the next increase in cases? The system can generate projections based on the approved models and available data. We can ask, simulate the next 72 hours, or compare this event with historical respiratory patterns, or what resources could be required if this trajectory continues. The critical principle is that AI output should be clearly labeled as analysis or simulation, not presented as established fact. Human experts remain in the decision loop. And then we can be able to switch from the BioShield into the digital twin node. As I said, this is just a prototype. I don't think we have much. And you can, wait, let's cancel this. Yeah. We have the digital twin, which will be probably accessible. We press on. The real world becomes a simulation environment. Instead of asking what is happening, we can ask what happens if we intervene. We can compare scenarios. Scenario A, no additional intervention. Scenario B, increased diagnostic capacity. Scenario C, deploy targeted public health resources. Scenario D, increase surveillance in selected regions. The system can then visualize projected differences, spread intensity, potential healthcare burden, resource requirements, geographic expansion, and economic consequences. The goal isn't to predict the future perfectly. No serious system should pretend it can. The goal is to create a decision laboratory where leaders can explore possible futures before committing real-world resources. And this brings us to the most important part of Atlas BioShield: action. Analysis without action is just an expensive observatory. At the bottom of the interface is the response orchestration bar. Depending on authorization and governance rules, decision makers could initiate workflows such as deploy additional diagnostics, alert designated healthcare networks, request resource allocation, coordinate supply chain routing, notify relevant public health authorities, or activate preparedness workflows. You can be able to notice the distinction. The resource orchestration down here. Now, deploy diagnostics, you can be able to alert hospitals, supply routing, notify authority, vaccine, pipeline. Notice the distinction. The Atlas BioShield isn't simply telling you that something is happening. It connects intelligence to coordinated response workflows. That's why I think of it as air traffic control for biological risk. Not because it controls the biology, but because it helps coordinate the human response. Underneath the experience, the MVP remains intentionally focused. The interface can be built with React and Next.js. For planetary visualization, we can use Mapbox GL or Cesium. For the real-time signals, can arrive through WebSockets. The state management can use Zastand or Redux. D3 can handle analytical visualizations, and Tailwind can provide the design system. The central object is simple, an outbreak signal. It contains an identifier, geographic location, biological types, severity, velocity, confidence, sources, and timestamp. That simplicity matters. We're not trying to build the entire world's biosecurity infrastructure on day one. We're building the command surface that can connect to those systems. So for your user journey, you can be able to walk through the complete experience. You open the Atlas BioShield, you immediately see the global biological risk map. A new anomaly appears in East Africa. The signal feed expands what changed. The user selects the cluster. The event timeline opens. They inspect how the signal developed. They examine its provenance. They ask the AI copilot to simulate possible trajectories. The digital twin generates scenarios. The user compares intervention options. And finally, authorized response workflows can be initiated. One continuous journey. Detect, verify, understand, simulate, coordinate, respond. Today, most systems are designed around individual domains. Hospitals see patients, labs see pathogens, agriculture sees crops, environmental sensors see ecosystems, government see reports. The Atlas BioShield proposes something different, a shared interface for biological situational awareness. A system where signals become intelligence, intelligence becomes simulation, and simulation supports coordinated action. Because the future of biosecurity shouldn't begin when the crisis becomes obvious. It should begin when the weak signal appears. That's the vision of Atlas BioShield, a planetary nervous system interface for detecting biological change, understanding what it means, and helping humanity prepare for what comes next. Also, that is a brief explanation of the entire platform. I hope you've enjoyed that. I'll drop another video next on another part, a core component of our building public, process. We're doing a lot, but today I think I'll be working on systemically dropping these videos.